Namaste children, how are you all? I hope you are fine. In the last classes we have discussed about the arithmetic progressions, general term of arithmetic progression, standard form of arithmetic progression, some of n terms of arithmetic progression and its applications. Now in this class we are going to discuss about a new chapter named as Polynomials. So this is new in the 10th standard, but it is already we have discussed about these polynomials and a few topics related to polynomials in 8th standard, even in the 9th standard. In 8th standard we have studied what are polynomials, types of polynomials, degree of a polynomial, classification of polynomials based on the degree of the polynomial, value of a polynomial, then zeros of a polynomial you have studied. Then after that remainders theorem, factors theorem, factorization, after that algebraic identities and their applications we have studied in the 9th standard. Now here we are going to revise those topics, a few topics like what are polynomials, what are non-polynomials, and what is the degree of the polynomial. Based on the degree of the polynomial, how many types of polynomials are there, and then their standard form, and zeros of those polynomials, value of those polynomials. After that we will study about the geometrical meaning of zero of a polynomial, that we will study for a linear polynomial, quadratic polynomial and cubic polynomial. Geometrical meaning is nothing but the number of zeros of a cubic or a quadratic or a linear polynomial. So now in detail we will discuss what is a polynomial. Poly, the word poly means what? Many. Poly means many. So you have come across the word in chemistry, polymers, in mathematics, polygons, in geometry, polygons, polygonia, polygons, polymers, and here it is polynomials. Poly means many, nomials means it is terms generally. An algebraic expression, polynomial is nothing but an algebraic expression which contains one or more than one term. An algebraic expression which contains one or more than one term is known as a polynomial. So in this 10th class we studied polynomials in one variable. Even in the 9th standard also we have studied polynomials in one variable. So what is algebraic expressions are polynomials? Yes or no? No. All algebraic expressions are not polynomials, but all polynomials are algebraic expressions. See, for example, x is an algebraic expression, x plus 2 is an algebraic expression, these two are polynomials, and they are also algebraic expressions. Now it is x to the power of 1 by 2 plus 1 or square root of x minus 1. So these are algebraic expressions, these two are algebraic expressions, but they are not polynomials, non-polynomials. Why they are non-polynomials? We will discuss here. So all these are algebraic expressions. But these two are polynomials in one variable and these two are non-polynomials. See, what are polynomials in general? An algebraic expression in which the exponent of the variable or the power of the variable is always a whole number. The power of the variable is always a whole number. What is the power? Here it is 1. It is a whole number. Here it is 1, whole number. X square plus 3x plus 2. Here 2, whole number. 3x for 1, whole number. 2 means it is 2 into 1 we can write. That is 2 into x power 0. So 0 is also a whole number. So that's why these algebraic expressions are known as polynomials, and here these are not polynomials. Why? Because here the exponent is 1 by 2, which is not a whole number, and similarly here root x minus 1. Root x means it is x to the power of 1 by 2 minus x. Again this is also a fraction which is not a whole number. The exponent is not a whole number. Hence these are non-polynomials and these are polynomials. Now x square plus 3y, this is also a polynomial, but it is a polynomial in two variables. X is one variable and y is another variable. So we will study in the 10th standard only polynomials in one variable. Polynomials in one variable. So this is x plus 2, x square plus 3, x square plus 2x plus 4, then x cube minus 3x minus 2. All these are polynomials, and these three are non-polynomials as the power or the exponent of variable is not a whole number. So that is the difference between algebraic expression and a polynomial. So poly means many, one or more than one terms they should contain. Such algebraic expressions are known as polynomials. Now here the exponent of this variable is what? 2. Here the exponent is 2. Here it is 1 and here it is 3. Here it is what? The exponent of this variable it is 1 and here it is 1. So now what is the degree of a polynomial? Degree of a polynomial. Degree of a polynomial. So degree of a polynomial is nothing but the highest power of the exponent. The highest power of the exponent of a polynomial is known as degree of the polynomial. That is the highest power, or it is what we can call it as the maximum power is known as degree of the polynomial. For example, if you take x is a polynomial. What is the exponent of this polynomial? It is variable, it is 1. Therefore its degree is what? 1. Its degree is 1. Now x square plus 2, x square plus 2. Here the x square 2 is their highest power, therefore its degree is 2. Now x square plus x plus 3x cube plus 3x cube. Here the power is 2, here the power is 1 and here the power is 3. Which is the highest power? It is 3, therefore its degree is 3. Now 4x to the power of 4 plus 7x cube plus 3. So which is the highest power? Here it is 4. Therefore its degree is 4. So degree of a polynomial is nothing but the highest power of the variable of a polynomial is known as degree of the polynomial. So based on the degree of the polynomials are classified as linear polynomial. Linear polynomial. What is a linear polynomial? We'll study here. Linear polynomial, then quadratic polynomial. Then the third one we'll study few types or few classification polynomial. Then cubic polynomial. Already you have come across their definitions and examples for this linear polynomial, quadratic polynomial and cubic polynomial. Linear polynomial means a polynomial with degree 1. A polynomial with degree 1 is called a linear polynomial. Then what is quadratic polynomial? Quadratic means quadrate. In Greek it is called quadrate. Quadrate means square. That is power 2. That's why it is quadratic polynomial means degree 2. So a polynomial with a degree 2 is known as a quadratic polynomial. A polynomial with a degree 2 is known as a quadratic polynomial. Then cubic means 3. A polynomial with a degree 3 is known as cubic polynomial. So here are some of the examples of linear polynomial. X plus 2, then it is x minus 2, then 7 minus x. All these are what? Linear polynomials, as their degree is 1. That's why these polynomials are known as linear polynomials. X square plus 3x, x square plus 3x plus 4. All these are what? Quadratic polynomials. Then cubic polynomials. X cube, 3x cube plus 7x, 4y to the power of 3 or y cube plus 7y. These are the examples of what? Cubic polynomials. Now we will study about these linear polynomials, cubic polynomials and quadratic polynomials, their standard form, that is their general form, and how to find the value of a polynomial, how to find the zeros of a polynomial, we will discuss now. It is so what are linear polynomials? Linear polynomials are nothing but polynomials with the degree 1 are known as linear polynomials. Quadratic polynomials are the polynomials with the degree 2. Then cubic polynomials are the polynomials with the degree 3. So examples we have discussed. Now we will discuss the standard form of the linear polynomial, standard form of the cubic polynomial and quadratic polynomial we will study. So the standard form of a linear polynomial is ax plus b. Ax plus b is the standard form of a linear polynomial. So then what is the standard form of a quadratic polynomial? Standard form of quadratic polynomial is ax square plus bx plus c. So linear polynomial. So what is its standard form? The standard form of a linear polynomial is ax plus b. Where a is not equals to 0. If a is equals to 0, then what will become? 0 into x is equals to 0. 0 plus b will get. So if b means what? If it is 0, 0 plus b will get. B means it is what? Bx to the power of 0. So the power is here, it is 0. Hence, if a is equal to 0, then that will not become a linear polynomial. So the general form of a linear polynomial is ax plus b, where a is not equals to 0. Similarly, quadratic polynomial, its standard form or general form is ax square plus bx plus c. Ax square plus bx plus c, where again a is not equals to 0. A is not equals to 0. If a is equal to 0, this term will become 0. Then it will become finally bx plus c, whose degree is 1. So it will become what? A linear polynomial, not a quadratic polynomial, if a is equals to 0. Then cubic polynomial. What is cubic polynomial? We have studied, and its general form or standard form. Cubic polynomial, it is ax cube plus bx square plus cx plus d, and where a is not equals to 0. Again, if a is equals to 0, 0 into x cube is equal to 0, it will become 0. Then bx square plus cx plus d will get, whose highest power is 2. Therefore, it will become a quadratic polynomial, not a cubic polynomial. So, cubic polynomial means whose degree should be 3. Whose degree is 3. Now, here what is a? A is x coefficient, b is the constant. Here a, b, c we have. A is x square coefficient, b is x coefficient, and c is the constant. In ax cube plus bx square plus cx plus d, where a is not equals to 0, in that a is x cube coefficient, b is x square coefficient, c is x coefficient, and d is the constant term. So this is the general form of linear polynomial, quadratic polynomial, and cubic polynomial. Now, how to find the value of a polynomial? How do you find the value of a polynomial? We have studied even in the 8th standard also, value of a polynomial. Then we will study 0 of a polynomial. So value of a polynomial for a given value of the variable. So let p of x is equals to x plus 2. P of x is equals to x plus 2. If x is equals to 2 means in the place of x, if you substitute, then what we get is p of 2. This p of 2 is nothing but value of polynomial p of x under the variable x. That is equals to, substitute x is equals to 2 in the place of x, that is 2 plus 2. 2 plus 2 is equals to 4. Therefore, p of 2 is equals to what it is? 4. P of 2 is equals to 4. P of 2 is equals to 4. This 4 represents what? Value of the polynomial p of x at x is equals to 2. At x is equals to 2. If x is equals to minus 2, then what it will become? If x is equals to minus 2, then what it will become? P of minus 2, that is equals to minus 2 plus 2. Minus 2 plus 2, what we got? 0. Therefore, P of minus 2 is equals to 0. Here 0 is nothing but, this result 0 is nothing but the value of the given p of x polynomial when x is equals to minus 2. When x is equals to plus 2, its value is 4. When x is equals to minus 2, its value is 0. So sometimes we will get 0 as the value. Sometimes we may not get the 0 as the value. Like this, we will find the value of a polynomial. So how do we find value of a polynomial? By substituting the value of the variable in the place of variable in the given polynomial, and on simplification we get the value of polynomial. So similarly, if x is equals to k, then what we get for this polynomial? If x is equals to k, then what we get is p of k is equals to, so x is equals to k, therefore it is k plus 2. So this is the value of the given polynomial p of x when x is equals to k. So this is known as value of a polynomial. Now what is 0 of a polynomial? If you observe here, 3 values we found for the same polynomial. P of x is equals to x plus 2. At x is equals to 2, we got 4. At x is equals to minus 2, we got 0. And at x is equals to k, we got k plus 2. If we observe the second value, when we substitute x is equals to minus 2, we got 0. Then minus 2 is known as 0 of the polynomial. 0 of the polynomial x plus 2. Why it is 0 of the polynomial? Because when we substitute x is equals to minus 2 in the given polynomial, we got its value is 0. Therefore, x is equals to minus 2. Now what we can conclude 0 of a polynomial? The value of a variable, that is the value of x or value of y or value of z, the value of a variable for which the value of the polynomial becomes 0. The value of the variable for which the value of the polynomial becomes 0 when we substitute in the place of the variable, then such values are known as, such values of the variable, see here, value of variable and value of polynomial. Values of variables are known as zeros of the polynomial. When we substitute in the place of that variable the given value, then the total value, if we get 0, then we call the substituted values are known as zeros of the polynomials. Zeros of the polynomial. So now we'll discuss how many zeros are there for a linear polynomial, how many zeros are there for a quadratic polynomial, how many zeros are there for cubic polynomial in this class. So we have studied for linear polynomial, how many zeros are there. We have studied using a factorization method, or by transposing those things, those variables and constants to one side, placing variables one side and constant the other side. Similarly, quadratic polynomial also we have studied, that is finding factors, that is called factorization. Now here we are going to study factor, that is finding zeros of the polynomial and of a quadratic polynomial and cubic polynomial here in this 10th standard, and also what it is division algorithm of cubic polynomials we will study here in the 10th standard. Now 0 of a linear polynomial. See here, the standard form of linear polynomial is ax plus b. How to find zeros of this polynomial? So let p of x is equals to ax plus b. To find zeros of p of x, take p of x is equals to 0. Take p of x is equals to 0. Why we are taking p of x is equals to 0? Because by substituting what value in the place of x, so that the resultant value will be 0. Hence we are taking p of x is equals to 0. That is ax plus b is equals to 0. So transpose plus b to that side, we get ax is equals to minus b. 0 minus b, it is minus b. Then x is equals to what it is? Transpose a to this side. Ax means it is a into x. It divides. Therefore it is b by minus b by a. Minus b by a we got. So minus b by a is the 0 of the polynomial ax plus b. Here minus, what is b here? B is known as a constant term. B is known as constant term. And what is a? A is nothing but coefficient of x. So coefficient of x. So there is a relationship between 0 of the linear polynomial with the coefficient of x and the constant term of that polynomial. That is minus b by a is the 0 of the polynomial ax plus b, which is minus of constant term divided by coefficient of x square. For example, find zeros of the polynomial x plus 2. Find zeros of the polynomial, 0 of the polynomial x plus 2. Let p of x is equals to, it is x plus 2. Then p of x is equals to 0, that is equals to x plus 2 is equals to 0. That is, by transposing plus 2 to that side, we get what it is? Minus 2. Therefore, x is equals to minus 2. So this is minus 2 is the 0 of the polynomial x plus 2. So here minus 2 is nothing but what it is. Minus 2 can be written as minus of minus 2 can be written as minus of 2 divided by 1, where minus 2 is nothing but what it is? Constant term. 2 is nothing but what it is? Constant term divided by 1 is nothing but what it is? Here 1. What is the coefficient of x in x plus 2? It is 1. So 1 is nothing but what it is? Coefficient of x. Coefficient of x. So like this we can establish a relationship between the 0 and the coefficient of variable in the for the linear polynomial, coefficient of x as well as the constant term of the linear polynomial. Similarly, like this we can establish a relationship between the zeros and the coefficients of the quadratic polynomial as well as a cubic polynomial. So this minus b by a is the 0 of the polynomial ax plus b, minus 2 is the 0 of the polynomial x plus 2. X plus 2. How many zeros we got? Only 1 0. So from this what we can conclude? For a linear equation, for a linear polynomial, at most we will have only 1 0. At most only 1 0. Now, geometrical meaning of the 0 of a polynomial. So here we will discuss first for linear polynomial. Geometrical meaning means what? Graphical representation. This is algebraic representation. Algebraic method to find 0 of the linear polynomial. Now here we are going to discuss that is geometrical meaning of the 0 of a linear polynomial. Linear polynomial. Geometrical means it is nothing but graphical representation of the 0 of the linear polynomial. So we discuss with an example. We have come across this in the 9th standard, that is drawing or constructing graphs for the linear equations in 2 variables. So let p of x is equals to, I am taking one example, x plus 2. P of x is equals to x plus 2. Let p of x is equals to x plus 2. How do we find its zeros? By using the algebraic method we have done. Here we got minus 2, we got that minus 2 is nothing but the 0 of the polynomial x plus 2. So convert this into what? Linear equation in 2 variables. For that what we will take y is equals to x plus 2. Y is equals to x plus 2. Here what is y? Y is nothing but what? P of x. P of x is nothing but what it is? Y. We are writing in the polynomial in 2 variables. That is x is 1 variable and y is 1 variable. So to draw the graph, first we have to write its order pairs. How to write the order pairs? We have come across even in the 8th standard as well as in the 9th standard. So you take at least 2 values for this. 2 values you take and represent this in the form of a graph. So a simple way, simple technique or simple method, let it is x and it is y. So here y, if x is equals to 0, if I put x is equal to 0, then 0 plus 2 on simplification what we get? 2. Therefore y is equals to 2. Y is equals to 2. Similarly, if I keep x is equals to minus 2, x is equals to minus 2. X is equals to minus 2 means minus 2 plus 2 it is 0 will get. Therefore the order pairs of this equation it is 0 comma 2 and it is minus 2 comma 0. Minus 2 comma 0. Now how to draw the graph of this linear polynomial? So draw two quadratic, that is 2 coordinate axis, x axis and y axis. On x-axis, take the scale, proper scale, x-axis and y-axis as 0, 2, minus 2, 0, small values are there. So take the scale as 1 unit is equals to 1 centimeter. And this will count as what? 0, 1, 2, 3. And this is minus 1, minus 2, and it is minus 3. On y-axis 1, 2, 3. This is y-axis and it is x-axis. Minus 1 and it is minus 2. Now x is equals to 0, y is equals to 2. This is x is equal to 0 and y is equals to 2. This is the point. So 0, 2. Now x is equals to minus 2, y is equals to 0. This is the point minus 2, 0. So join these 2 points, we'll get a straight line. We'll get a straight line. So that straight line will give you what? Graphical representation of x plus 2. Y is equals to x plus 2. So that is, this will give you y is equals to x plus 2. This graph, that is, what is the nature of the graph of a linear polynomial? Will get always a straight line. This straight line is intersecting the x-axis at minus 2, 0. So this is called point of intersection of the graph of the linear polynomial with x-axis. And what is its coordinate? It is minus 2. What is its coordinate? The coordinate of that intersecting point, it is minus 2. What we got is 0 of the same polynomial by algebraic method, it is minus 2. So from this what we can conclude? The geometrical meaning of the 0 of a linear polynomial or any polynomial. The x coordinate of point of intersection of the graph of a polynomial with x-axis. That x coordinate is known as geometrical meaning, that is 0 of the polynomial in the graphical representation. So we have studied for linear polynomial, it intersects the x-axis at most one point. That's why linear equation will have only 1 0 at most. What about quadratic polynomial? Geometrical meaning of this quadratic polynomial. So this quadratic polynomial and a cubic polynomial, the graphs if we don't have, just we will see the graph of a quadratic polynomial is a parabola curve will get, that parabola curve or a bell-shaped curve will get. So the general form of a quadratic polynomial is it is ax square plus bx plus c we have studied. So its graph when we draw, that is by taking some examples. So this is called a quadratic polynomial, and if you draw, it will get different curves. It intersects. This shaped curve is known as what? Bell-shaped curve or a parabola curve. This is the nature of a graph of a quadratic polynomial. What is its name? It is parabola. What is the name? It is parabola curve, or it is also known as bell-shaped curve. So this parabola curve is intersecting at 2 points. It is intersecting at 2 points. Hence, for a quadratic polynomial, it will have 2 zeros at most. This is one way. The other way also, if you draw like this, we will get at 2 places it is intersecting. Here also we will get like this. At 2 places it is intersecting. Or if you draw one, we may get just at one place it may intersect, or it may intersect at one place. So this point is known as 0 of the polynomial. So it has maximum 2 zeros of the polynomial. 2 zeros of the polynomial. And sometimes you may not find any 0 of the polynomial. Like this you will get the quadratic polynomial. Means that graph will not intersect the x-axis. What is 0? Geometrical meaning of 0 of a polynomial? The x coordinate of point of intersection of the graph of a polynomial which intersects the, that is the intersecting point of x-axis and the graph is known as 0 of the polynomial. So similarly, if you take for a cubic polynomial, if you draw for a cubic polynomial, so again that cubic polynomial will intersect the x-axis at 3 places at most. Why? Because its degree is 3 and it will its zeros are 3 zeros will get, and 3 factors will be there for the cubic polynomial. So the general form of a cubic polynomial, it is ax cube plus bx square plus cx plus d. Here what is the highest power? It is 3. Highest power is 3. So how many zeros will be there? 3 zeros at most. 3 zeros at most. Here 2 zeros at most. For a linear polynomial, only 1 zero at most. If you draw the graph of a cubic polynomial, it may get like this. That means it is intersecting at 3 places. At 3 places. So these how many points of that is intersecting points is there for the graph as well as the what it is x-axis. That number will give you number of zeros of the given quadratic polynomial or cubic polynomial or linear polynomial or any other polynomial. So what is the use of this geometrical meaning of what is the necessity of knowing this geometrical meaning of zero of a polynomial means if you know we can identify how many zeros are there. It is equals to what? The number of intersecting points of the graph with the x-axis. If 3 points are there intersecting points, then it will have 3 zeros. Only 1 point is there intersecting point, only 1 zero. At 4 places it is intersecting, then how many zeros will be there? 4 zeros. So using that graphs when you are given some graphs and you need to identify the how many zeros are there for the given polynomials. For example, you see here this is now how many polynomials are how many zeros are there for this? Here it is 1, 2, 3. 3 zeros are there. 3 intersecting points are there, therefore 3 zeros are there. Now how many points are there like this? If you see here 1, 2, 3, 4. So how many zeros are there here? 4 zeros are there, and here 3 zeros are there. And then here how many zeros are there? And here it is how many zeros is there? It is intersecting. That means it is coinciding at only 1 point. Therefore it is only 1 zero is there. Now here how many zeros are there? This is x-axis and this is the graph. How many zeros are there? This graph is not intersecting anywhere on the x-axis. Therefore here no zeros or no zero. For this graph there is no zero. Here 4 zeros and here 3 zeros. Like this we will identify the number of zeros of a given polynomial whose graph is given. And what I can conclude, for a linear polynomial, how many zeros is there? At most only 1 zero is there. For a quadratic polynomial, at most how many zeros will be there? 2 zeros. And for a cubic polynomial, at most how many zeros are there? 3 zeros. From this what we can conclude, for any polynomial p of x, whose degree is n, then how many zeros will have? N zeros at most. N zeros at most. At most means is maximum. For any polynomial with degree n will have n zeros at most. That is maximum number of zeros are n. So from this what we have studied today, it is how to what is the meaning of geometrical meaning of zero of a polynomial, relationship between the linear polynomial and its coefficients, and then how to identify the number of zeros from the given graph. Did you understand, children? And in the last class we have discussed the introduction of this polynomials chapter, in that degree of a polynomial, value of a polynomial, zero of a polynomial, and factors of polynomials, especially the geometrical meaning of zero of a polynomial we have discussed, and the graphical representation of linear polynomial we have discussed, and the nature of the quadratic equation, the graphical nature of the quadratic equation we have discussed in the previous class. Now we are going to discuss about relationship between zeros and coefficients of a polynomial. Now what is zero of a polynomial? We have discussed yesterday. Zero of a polynomial is nothing but what it is, value of x for which p of x is equals to 0. What is p of x? Here it is, p of x is a polynomial. Let p of x is equals to ax square plus bx plus c. It is a quadratic polynomial. So the value of x, here x is nothing but what? Variable. The value of x for which p of x is 0, then the value of x is known as 0 of the polynomial p of x. We have discussed in the last class. Now what are coefficients? coefficients are what we discussed. Coefficients what, that is the x square is there for here. X square, a is the coefficient of x square and b is the coefficient of x. B is the coefficient of x. Here for this a and b are what, the coefficients. A and b are known as coefficients. A and b are known as what? Coefficient. Coefficients or coefficient. Ax square plus bx plus c. In that a and b are known as coefficients. Even if you take a general form of a linear polynomial, p of x is equals to ax plus b. Ax plus b. Here this ax plus b, a is known as what it is? Coefficient. A is known as coefficient. Similarly, if you take a cubic polynomial, p of x is equals to, it is ax cube plus bx square plus cx plus d. Here a, b and c are known as what? Coefficients. So now, what about this c and what about this b? What about this d? They are known as what? Constants. What it is? D is known as a constant, b is known as a constant, a is also known as a constant. So sorry, c is known as a constant here. C, b, d. C is the constant in the quadratic polynomial, b is the constant in it is a linear polynomial, and d is the constant in the cubic polynomial. Now we are going to establish a relationship between zeros, that is values of x, and coefficient, that is a, b, c, and constant, it is d. C, b, d are the constant. What is the relationship between the zeros and the coefficients of the polynomial? So this is about coefficients, zeros of a polynomial. So first we'll discuss about a linear polynomial. What is the general form of a linear polynomial? It is p of x is equals to, that is ax plus b, where a is not equals to 0. This is general form of a linear polynomial. Now what is the zero of this polynomial? To find the zero of the polynomial, what we will do? We will take a p of x is equals to 0 or not? Yes. Then what is p of x? Here it is ax plus b, that is equals to 0. Transpose plus b to that side, RHS will get plus b will become minus b. Then transpose a to the RHS side. As here ax means it is a into x. A is multiplied, therefore x is equals to what? Minus b by a. What is x here? It is what is x here? It is a variable. Now what is minus b by a? It is the value of x for which p of x is 0. Therefore minus b by a is known as 0 of the linear polynomial ax plus b. If you observe here, that is what we call here a is known as what? Coefficient of x, and what is called here it is b is known as constant. So if you observe here, minus b is nothing but what it is? Constant term. B is nothing but constant term, and what is a is nothing but coefficient of x. Constant term divided by coefficient of x. So here 0 is 0 of the linear polynomial. It is depending on its coefficient and constant. That is minus b by a is equals to minus of constant term divided by coefficient of x square. This is the relationship between 0 of a linear polynomial with its coefficient and constant term. That is minus b by a, which is equals to minus of constant term divided by coefficient of x. So based on this we can write its zeros of the polynomial. For example, x plus 2 is there. Then what is its zero of the polynomial? 0 of the polynomial x plus 2, it is minus b by a. What is b here? It is a constant term. If we compare this with our general form, ax plus b. So b stands for 2, and here a stands for, here there is no coefficient, means it is 1. A is equals to 1. Minus b by a means it is minus b is equals to what? 2. That is minus 2 by a is equals to 1. which is equals to minus 2. So like this we can find the zeros using the concept of that is a relationship between the zeros and the coefficient and constant term of a linear polynomial. For example, if you want to find for 4x minus 2, then what is the zero of the polynomial 4x minus 2? That is minus of b by a, that is equals to minus b is nothing but what here it is, the constant term. What is the constant term here? It is minus 2. Therefore, we will write it as minus 2 in the place of b, and a is nothing but what? The coefficient of x. A is nothing but coefficient of x. What is coefficient of x? Here it is 4. That is equals to minus into minus, it is plus 2 divided by 4. 2 ones are 2 twos are. We'll get it is 1 by 2. 1 by 2 will get. Is it clear, children? So what is the zero of this polynomial? It is 1 by 2. Similarly, if we have like this minus 4x and minus 2 is there, then what is the zero of this polynomial? So that is minus b by a, which is equals to minus of b is equals to the whole constant term, which is minus 2 divided by a is nothing but what it is? Coefficient of x. Here coefficient of x it is minus 4. Now simplify this. Minus into minus it is plus 2 divided by minus 4. 2 ones are 2 twos are. We will get 1 by 2, and we have minus sign is there. Therefore it is minus 1 by 2. Minus 1 by 2. Like this we will establish or we will verify the relationship between zeros and the coefficients of a linear polynomial. So the relationship it is what? For zero of a linear polynomial, it is nothing but minus of constant term divided by coefficient of x. Minus of constant term divided by coefficient of x. Did you understand, children? What are coefficients? What is zero of a polynomial? What are constants? And the relationship between the zero of a polynomial and coefficient of a linear polynomial. That is x is equals to minus b by a. General form, from general form we got x is equals to minus b by a. Did you understand, children? Now we will discuss relationship between zeros and coefficients of a quadratic polynomial. Before we discussed about the linear polynomial. Now in general, let alpha and beta are the zeros of a quadratic polynomial. We know the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equals to 0. And also we know that its degree is 2. What is the degree of the quadratic polynomial? Degree is nothing but the highest power of the variable. Here it is 2 is there. Therefore its degree is 2. So as we have studied, how many zeros will be there if degree is 2 for a polynomial? At most 2 zeros. Let those 2 zeros are alpha and beta. Both are Greek letters, alpha and beta. Then the alpha and beta are the zeros of a quadratic polynomial ax square plus bx plus c, where a is not equals to 0. Then what we can write? Ax square plus bx plus c, that is equals to quadratic polynomial is equals to, in 9th class you have studied. So if alpha is the zero of your polynomial, then what is the factor? By using the factors theorem, alpha minus beta, if alpha and beta are the zeros of the polynomial, then what are the factors? Using factors theorem, can we write x minus alpha is one factor and x minus beta is one factor? Is it clear or not? X minus beta is one factor and both are multiplied with a constant term called k. We studied in the 9th class. If alpha is 1, 0, then its factor will be what? X minus alpha. Similarly, beta is 1, 0, then its factor will be x minus beta. So therefore, ax square plus bx plus c is equals to, we get it is by multiplying the factors of the polynomial ax square plus bx plus c, whose zeros are alpha and beta, that is equals to k into x minus alpha into x minus beta. Now multiply this k into, multiply these two, x into x it is x square, then x into minus beta it is minus beta x, then minus alpha into x it is minus alpha x, minus alpha x, minus into minus it is plus alpha into beta it is beta, alpha into beta, that is equals to k into x square So here interchange this, it is minus alpha x minus beta x plus alpha into beta. Multiply with k, that is equals to kx square minus k into alpha x minus k into beta x plus k into alpha into beta, k into alpha into beta. Now that is equals to kx square minus k, here minus k and here minus k is common, is there, or minus x is there common, minus k is there, minus k, and by taking minus k, then what is left here, it is plus alpha plus beta into x. So x is also common, is there from these two terms, take x common, and minus k is also common, is there, take minus k also common, plus k into alpha plus beta, k into alpha plus beta. Now this we got again a quadratic equation if variable x and power it is 2. Now comparing this quadratic polynomial and this quadratic polynomial by comparing the coefficients, by comparing above quadratic polynomials, by comparing above quadratic polynomials. So what we can write about their coefficients? Here k represents what? X square coefficient minus alpha into minus k into alpha plus beta will represent coefficient of x. K into alpha into beta will represent what is a constant term. So here x square coefficient is a and here x square coefficient is k. Therefore a is equals to k. A is equals to k. Similarly, the coefficient of x here it is b, that is b is equals to, what is the coefficient of x here, it is this total term, that is minus k into alpha plus beta, minus k into alpha plus beta. Similarly, the constant term, what is here the constant term, it is c is equals to constant term, what it is, k into alpha plus beta, k into alpha plus beta. Now compare here, a is equals to k from these two equations. From these two equations, a is equals to k and b is equals to minus k into alpha plus beta. Substitute a is equals to k in this equation, what we get, it is b is equals to minus k is equals to what it is, a. Write in the place of k as a, that is equals to minus a into alpha plus beta. Now transpose minus a to this side, here it is multiplying, therefore it divides. By transposing, what we get, it is alpha plus beta is equals to b divided by minus a, that is minus b by a, minus b by a. What are alpha and beta? Alpha and beta are nothing but zeros of the quadratic polynomial ax square plus bx plus c, that is sum of the zeros. Here we got sum of the zeros is equals to minus b by a. Now what is b here? X coefficient. What is a here? X square coefficient. X square coefficient, that is equals to minus of b is equals to x coefficient, that is coefficient of x divided by a is equals to coefficient of x square, coefficient of x square, coefficient of x square. Therefore what we can write, the sum of the zeros is equals to, that is alpha plus beta is equals to minus b by a, that is minus of coefficient of x divided by coefficient of x square. So similarly we can write for the product. So now if we compare here again this two a and c, if we compare from this, what we can write, c is equals to k into alpha into beta, but k is equals to what it is, a. So write a alpha into beta. Now transpose a to this side, we get c by a, that is equals to alpha into beta, alpha into beta. What are alpha and beta again? They are the two zeros of the quadratic polynomial ax square plus bx plus c. So that is alpha and beta, alpha into beta, product of the zeros. Therefore alpha into beta, that is product of the zeros, is equals to c by a. Now if we compare the coefficients of this given quadratic polynomial ax square plus bx plus c, C by A we got here. C is equals to what is here? It is a constant term, and A is equals to what it is again? Coefficient of x square. Therefore, product of the zeros is equals to constant term divided by coefficient of x square. Coefficient of x square. So that is finally what we can write. Sum of the zeros is equals to minus b by a, and product of the zeros is equals to what we can write? Product of the zeros is equals to c by a. So this is the relationship between sum of the zeros and product of the zeros. That is relationship between zeros and coefficients of a quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where a is not equals to 0. So as these two are zeros, using the factors theorem, we can write x minus alpha and x minus beta are the two factors of the polynomial ax square plus bx plus c. Now we are multiplying with k. Why we are multiplying with k? K is a constant. We will get the same, but it will get in the form of multiples. That is, by simplifying this, we will reach kx square minus k into alpha plus beta into x plus k into alpha beta. Now this is also a quadratic polynomial. Now compare this quadratic polynomial and given quadratic polynomial. Then write what is a, what is b, what is c. From that we can reach to alpha plus beta. That is, sum of the zeros is equals to b divided by, that is minus b by a. That is coefficient of x divided by minus of coefficient of x divided by coefficient of x square. Product of the zeros is equals to c by a. That is constant term divided by coefficient of x square. So this is about the relationship between zeros and coefficients of a quadratic polynomial. Now we will verify whether this relationship is satisfied or not with some examples. Is it clear, children? Now we will discuss one sum from exercise number 2.2. The first sum. Find the zeros of the following quadratic polynomials is one part, and verify the relationship between zeros and coefficients of that quadratic polynomial. In these two bits are there. First bit is find the zeros of the following quadratic polynomials, and then verify the relationship between the zeros and the coefficients of the given polynomial. So here, first question, x square minus 2x minus 8. X square minus 2x minus 8. Is it a quadratic polynomial? Yes, because its degree is 2 and variable here it is x. Now what is the coefficient of x? Here it is. So when we compare this x square minus 2x minus 8 with the general form of the quadratic equation. What is the general form of the quadratic equation? Ax square plus bx plus c. So here what is a here? A is nothing but what? X square coefficient, as here there is no number means it is always 1. Therefore a is equals to 1. Then b is equals to x coefficient. X coefficient it is what? Minus 2. Then c is equals to what? Constant, it is minus 8. Minus 8. Now that is we have identified the coefficients and the constants. Now we need to find the zeros of the quadratic polynomial. So to find the zeros of the quadratic polynomial, so what we will take of the quadratic polynomial? We will take p of x is equals to, if it is p of x, then we will take x square minus 2x minus 8 is equals to 0. Now solve this, that is x square minus 2x minus 8. You have studied in the 9th standard splitting the middle term. Which is the middle term? Here it is minus 2x is the middle term. So you need to split the middle term in such a way that the factors of the product of a and c, that is coefficient of x square and the constant term, that product factors you need to write. That from that pair of factors, identify which pair of factors will satisfy the middle term, either by addition or by what it is subtraction of the pair of factors. That like that will split the middle term. Here x is equal x square coefficient it is 1, that is 1 into constant term is equals to minus 8. Therefore, what is the product it is? Minus 8 is the product. Means you need to multiply the constant term and the x square coefficient. You will get a product. To that product, write the factors which satisfies the middle term, either by adding or by subtracting. Now we see here minus 8 factors. What we can write here? It is 1 into minus 8 we can write, or minus 1 into 8 we can write. Then 2 into 4, 2 4s are 8, 2 into minus 4, or minus 2 into 4 also we can write. Any other factors are there other than this? Only these four pairs of factors we get. Now identify which pair will satisfy the middle term minus 2. Here 1 and minus 8, if you add these two, what we get? 1 minus 8 will get, it is minus 7, which is not equals to minus 2. Or by adding 1 plus minus 8, by subtracting these two, what we get? It is 1 minus of minus 8, it is plus 9 you will get, which is not satisfied. Then minus 1 plus 8 will get plus 7, it is not equals to minus 2. 2 minus 4, by adding these two, what we get? That is by adding this pair of factors, that is 2 plus of minus 4, that is equals to 2 plus into minus, it is minus 4. 2 minus 4, what we get? Two integers we are subtracting here. So subtract the smaller number from the greater number and take the greater number sign. 4 minus 2, it is 2, and its sign will be minus 2. Now it is satisfied or not? Here the middle term it is minus 2, and here we got minus 2 by adding the two factors, this a pair of factor 2 and minus 4. So like that we should split the middle term, then we get x square. So this is minus 2x, we are going to write it is plus 2x, this is plus 2x, and it is minus 4x, minus 8 is equals to 0. Like this we will split the middle term and we write the factors. Now take first two terms and next two terms. From these two terms identify the common term. Here x square means it is x into x, that is x, we can take common. 2x means it is 2 into 2, x is there in both the terms common, take x, then what is left here? X, plus when we take x common, then what is left here? It is 2. Now here minus 4x, it is minus 8. Minus 8 can be written as minus 4 into 2. Minus 4 into 2. So can we take minus 4 common? Yes. Then what is left here? It is x. And here what is left? It is plus 2, which is equals to 0. Now x plus 2 is one factor. The leftover terms, that is x and minus 4. That is x minus 4 into x plus 2 is equals to 0. Now here we got two factors. That is now x minus 4 is equals to 0, or x plus 2 is equals to 0. That is transpose minus 4 to that side, it will become plus 4. 0 plus 4 is equals to 4. Therefore x is equals to 4, and x plus 2 is equals to what it is. So transpose plus 2 to that side will get minus 2, and x is equals to minus 2. Now the zeros of the polynomial. Zeros are nothing but what? The values of x for which the total value of the polynomial will be 0. We have equated it as 0, and we got two factors. From that untransposing, we got x is equals to 4 and x is equals to minus 2 are the two zeros. So first part of the problem is over. That is, find the zeros of the following quadratic polynomials. How do we find zeros of the quadratic polynomial? By splitting the middle term. By splitting the middle term, or by using, that is, factorization, finding its factors. So after finding, now we need to verify the relationship between the zeros and coefficients. What is the relationship between the zeros and the coefficients? It is sum of the zeros. Verification. So now we are going to verify. So sum of the zeros is equals to, what is that? It is sum of the zeros of a quadratic polynomial is equals to minus b by a, where b is coefficient of x and a is coefficient of, it is x square, or you write it is, that is minus coefficient of x divided by coefficient of x square. Now sum of the zeros means we got zeros, that is 4 plus, sum of the zeros is equals 4 is 1 0, the other 0 it is minus 2, 4 plus of minus 2 we are adding here, it is on the left hand side. we are adding the zeros. X is equals to 4 and x is equals to minus 2. Those are the two zeros. That is 4 plus of minus 2. That is equals to minus b by a. What is here minus? What is b here? Minus 2. Minus b by a means it is minus of b is equals to what? Minus 2 divided by a. A is equals to what it is? 1. Now simplify. That is, how do we add? 4 plus into minus, minus 2. That is equals to minus into minus, it is plus 2 divided by 1. 4 minus 2, it is 2. That is equals 2 divided by 2 is equals to 1. That is LHS is equals to RHS. Hence it is verified or not. That is sum of the zeros from which we found the zeros, already we found the zeros, that sum is equals to 2 we got, and the verification, that is how it is related to the coefficient, that is minus b by a is there. In when we substitute minus b value, that is b value and a value, we got same on LHS and RHS. Therefore, or hence it is verified. Hence it is verified. So like this we will find the zeros of the quadratic polynomial, and also we will verify the zeros and the coefficients of the polynomial. So did you understand, children? One of the important and easiest concept it is. We will discuss with one more sum from the same bit. Now we will discuss fifth sum from the same bit. T square minus 15 here. T square minus 15. So here we don't have the middle term here. We have, that is x square term is there, and here we have the constant is there. There is no middle term. There is no middle term means it will be always 0. Here which is the variable? T is the variable. This polynomial is derived in the variable t. So when we compare this with our general form of the quadratic equation, that is ax square plus bx plus c. When we compare with this quadratic polynomial, here x is nothing but what it is? T. What is the coefficient of t? Here it is. There is no coefficient means it is 1. Therefore, a is equals to what? 1. And here bx, x term is not there, and we have directly constant is there. Therefore, b is equals to 0, and constant term c is equals to minus 15. Minus 15. Now, how to find these zeros of t square minus 15? We need to take to find zeros of a quadratic polynomial, that is t square minus 15 is equals to 0. Why we are taking 0? For what value of t? It's the value of the total t square minus 15 is 0. So we need to find t square. So here we can apply by transposing this minus 15 to that side. What we get, it is t square is equals to 15. So now t we need to find. To find t square should be transposed to that side. So when you transpose the RHS, the square will become square root. That is square root of 15 we will get. But here square root of 15 will get 2 values, plus or minus 2 values will get. Therefore, the zeros of the polynomial are, it is root 15, that is plus 15, and one more it is t is equals to minus root 15. Minus 2 root 15, minus root 15 plus root 15 are the zeros of the polynomial t square minus 15. Like this we can apply, we can find its zeros, especially this kind of sums. We can also apply the identity of algebraic identity also we can discuss. That I'm going to explain at here. That is t square minus 15 is equals to 0. So t square minus 15, can we write square root of 15 whole square? Square and square root will be cancelled, will get again 15, that is equals to 0. Now it is in the form of a square minus b square is equals to 0. That is a is equals to t, b is equals to root 15. So what is the identity? It is a square minus b square is equals to a plus b into a minus b. That is t minus root 15 into t plus root 15. That is equals to 0. That is a plus b into a minus b, or a minus b into a plus b. Now t minus root 15 is equals to 0. T plus root 15 is equals to 0. Now transpose minus root 15 to the RHS, will get plus root 15. Therefore t is equals to root 15 or plus root 15. Here transpose plus root 15 to RHS, we get t is equals to minus root 15. So this method it is what? By using the algebraic identity. This is direct method we applied here. So you can choose any one method, not required here. This is R method. Now we found what? The zeros of the quadratic polynomial. Next what we have to do? We have to verify the relationship between the zeros and the coefficients. How to verify that relationship? So verification. So verification is equals to what it is? Sum of the zeros is equals to sum of zeros is equals to sum of zeros is equals to it is minus b by a or minus of coefficient of x divided by coefficient of x square. Sum of the zeros. What are the zeros which we got? Root 15 plus this is minus root 15 we got. That is equals to minus b is equals to what here? In the question there is no middle term, therefore b is 0 divided by a is the x square coefficient. So a is equals to what it is? 1. Substituted here. Now what it is? Root 15 plus into minus minus root 15, that is equals to 0 by anything is equals to 0. Root 15 minus root 15 both will be cancelled, get 0, that is equals to 0. It is verified. Sum of the zeros is verified. Is it clear? Sum of the zeros we got root 15 and it's the relationship is also we got 0 only. Now we will discuss product of the zeros. Product of the zeros. Product of zeros is equals to, it is c by a. C by a, where c is the constant term, a is the coefficient of x square. Product means alpha into beta, that is first 0 it is root 15 into second 0 it is minus root 15 minus root 15, that is equals to c is equals to what? C is equals to constant term, what it is? Minus 15 divided by a is equals to coefficient of x square, it is 1. That is coefficient of a is nothing but coefficient of x square. Here x is nothing but what it is? T is the variable. Now plus into minus, it is minus root 15 into root 15. That is root 2 into root 2, it is 2. Root 15 into root 15, it is simply it is 15. That is equals to 15 minus 15 divided by 1 is equals to minus 15. Again we got LHS is equals to RHS. Both are equal. Both are equal on left hand side or RHS side. That is, therefore it is verified. It is verified. Like this we can verify the zeros by finding zeros of the quadratic polynomial, and also we can verify the relationship between zeros and coefficients. Did you understand this? How to find the zeros and how to verify the zeros of the quadratic polynomial. And in the last class we have discussed the relationship between the coefficients of a quadratic polynomial and the zeros of the quadratic polynomial. Similarly, the relationship between the zeros and coefficient and constant of a linear polynomial. And now we are going to discuss, and its applications also we discussed by solving some of the problems. Now we are going to discuss about when we know the zeros of an equation, zeros of a quadratic polynomial, zeros of a quadratic polynomial, then how to find out the required quadratic equation. So here we know the two zeros of the quadratic polynomial, then how to find those zeros are zeros of which quadratic polynomial. Means we can find the quadratic polynomial when we know the zeros of a quadratic polynomial. For that, if alpha and beta are the two zeros of a quadratic polynomial, or the zeros of a quadratic polynomial, alpha and beta are the two zeros of a quadratic polynomial, then the polynomial is k into whole, that is x square minus k into x square, k into whole x square minus alpha plus beta into x, alpha plus beta into x, that is alpha and beta plus means it is sum of the two zeros of the given polynomial into x plus alpha into beta, that is product of zeros. That is, we can find the quadratic polynomial when we know the two zeros. That by using the concept, by using the formula k into whole x square minus alpha plus beta into x plus alpha into beta, or in words it is k into whole x square minus sum of zeros of the polynomial into x plus product of the zeros, where alpha plus beta is equals to sum of the zeros and alpha into beta is equals to product of the zeros. So this quadratic polynomial, this formula we can use to find the quadratic polynomial when we know the two zeros of the quadratic polynomial. Is it clear, children? Now we will discuss problems related to this concept. Now exercise number 2.2, second bit. Find a quadratic polynomial. Find a quadratic polynomial each with the given numbers. You are given some numbers as the sum and product of its zeros respectively. So two numbers are given from each problem. The first number will represent the sum of the zeros of a quadratic polynomial. Second number will represent the product of the zeros of the quadratic polynomial. Then we need to find the quadratic polynomial. So using the concept of quadratic polynomial, when we know the zeros of the quadratic polynomial as alpha and beta, then the quadratic polynomial is k into whole x square minus alpha plus beta into x plus alpha into beta. So that concept will apply to find the quadratic polynomial when sum and product of the zeros are given. So write first given data. So given it is 1 by 4 will represents what? Sum of the zeros, that is alpha plus beta is equals to 1 by 4, and alpha into beta, that is product of the zeros, is equals to minus 1. So required quadratic polynomial or quadratic polynomial is equals to k into x square minus alpha plus beta into x plus alpha into beta. Now substitute in the place of alpha plus beta as 1 by 4 and alpha into beta as minus 1. Then simplify, we get the required quadratic polynomial, that is k into x square minus alpha plus beta is equals to 1 by 4 into x plus alpha into beta is equals to what it is? Minus 1. That is equals to k into x square minus 1 into x, it is minus x divided by 4 plus into minus is equals to, it is minus, we will get minus 1. Now here for the middle term we have denominator is there. Make the denominators of all the terms equal by taking the LCM. X square means it is x square by 1. Minus 1 means it is minus 1 by 1. So the LCM of the denominators 1, 4 and 1 will be 4 only. Therefore k into denominator is 4. Now divide 4 with 1. 1 4s are 4. 4 into x square it is 4x square minus 4 1s are 4. 1 into x it is 1x, or simply it is x minus. So here minus 1 means it is 1 by 1. So when we divide 4 with 1, the quotient is 4. 4 into 1 it is 4 minus 4. Now this is the required quadratic polynomial when sum of the zeros is equals to 1 by 4 and product of the zeros is equals to minus 1. We just substitute in the place of alpha plus beta as the sum of the zeros and product of the zeros as alpha into beta. Then we will simplify. We can get the required quadratic polynomial when we know the sum and product of the zeros of a polynomial. Can we discuss one more, sir? Yes. Now the second bit, from the second sum, root 2 comma 1 by 3. Root 2 represents sum of the zeros and 1 by 3 represents product of the zeros. Then what is the quadratic polynomial? We have to find out. So given data it is alpha plus beta, that is sum of the zeros is equals to root 2. Product of the zeros, that is alpha into beta, that is equals to 1 by 3. So write given data as alpha plus beta, that is sum of the zeros is equals to root 2. Product of the zeros is equals to 1 by 3. Now required quadratic polynomial is equals to what is the statement here? It is required polynomial or quadratic polynomial is equals to k into x square minus alpha plus beta into x plus alpha into beta. Now substitute in the place of alpha plus beta as root 2 and alpha into beta as 1 by 3. Then simplify. That is k into x square minus alpha plus beta is equals to root 2 into x, root 2x plus alpha into beta, product of the zeros is equals to 1 by 3. Again take the common denominator by taking the LCM. So here x square means it is x square by 1. Root 2x means it is root 2x by 1. Here the denominator is 1 and here the denominator is 1. So the LCM for the three denominators 1, 1 and 3 it is 3. Now the denominator is 1. When we divide 3 with 1 we get quotient as 3. 3 into x square it is 3x square minus, again here 1 is the denominator, divide 3 with 1 we get 3 as the quotient. 3 into root 2 it is 3 root 2, 3 root 2 x plus 3 ones are 3, 1 is the quotient, 1 into 1 it is 1. So now the required quadratic polynomial is k into whole into 3x square minus 3 root 2x plus 1 whole divided by 3. Like this we will find the quadratic polynomial when we know the zeros and the product of the quadratic polynomial by using k into whole x square minus sum of the zeros of the given quadratic polynomial into x plus alpha into beta, that is product of the zeros. Is it clear, children? Now the same kind of sum we will discuss one more. Find a quadratic polynomial whose zeros are minus 2 and minus 5. This problem is different from the previous problem. In the previous problem, sum of the zeros and product of the zeros are given directly, whereas here just two zeros of the polynomial, quadratic polynomial are given. That is minus 2 is one zero and minus 5 is other zero, that is second zero. Here minus 2 and minus 5 are just zeros of the polynomial, not the sum or the product of the zeros of a quadratic polynomial. That is the difference between the previous sum and this sum. So here what are given? Given here the two zeros are given. Let the two zeros are alpha is equals to minus 2 and beta is equals to minus 5. So what we need to find a quadratic polynomial. In the quadratic polynomial we should know to find quadratic polynomial sum of the zeros and product of the zeros. Then we will substitute those values in the place of sum of the zeros and product of the zeros and we will simplify. Here the two zeros are given alpha and beta as minus 2 and minus 5. So we don't know what is the sum. So first you find the sum of the zeros, that is alpha plus beta is equals to minus 2 plus minus 5. Minus 2 plus minus 5. Minus 2 plus into minus minus 5 will get. That is minus 2 minus 5 is equals to minus 7. Similarly, product of the zeros alpha into beta is equals to minus 2 into minus 5. Minus 2 into minus 5. Minus into minus it is plus, 2 into 5 is 10. Therefore, product of the zeros is equals to 10. Sum of the zeros is equals to minus 7. Now we know the sum of the zeros as minus 7 and the product of the zeros is 10. So now quadratic polynomial is equals to the required quadratic polynomial. Quadratic polynomial is equals to what is that? It is k into x square minus alpha plus beta into x plus alpha into beta. K into whole x square minus alpha plus beta into x plus alpha into beta. Now substitute alpha plus beta as minus 7, alpha into beta as 10. Then you simplify. That is equals to k into x square minus alpha plus beta is equals to minus 7 into x plus alpha into beta is equals to 10. That is equals to k into x square minus into minus it is plus 1 into 7 it is 7 into x it is 7x plus 7x plus 10. So this is the required quadratic polynomial when we know the two zeros of the polynomial minus 2 and minus 5. This is here the individual zeros are given. We need to find the quadratic polynomial. Means first we have to find the sum of the zeros, then we have to find the product of the zeros. After that, substitute in the quadratic polynomial when we know the sum of the zeros and product of the zeros, and simplify, we will get the required quadratic polynomial. Is it clear, children? This is a different problem. It is a different problem. Now we will discuss relationship between zeros and coefficients of a cubic polynomial. So cubic polynomial, the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equals to 0. How many zeros are there for a cubic polynomial? At most 3 zeros will be there. If 3 zeros, let the 3 zeros of the cubic polynomial ax cube plus bx square plus cx plus d, where a is not equals to 0, are alpha, beta and gamma. This is the third letter, gamma, a Greek letter. Alpha, beta and gamma are the zeros of a cubic polynomial ax cube plus bx square plus cx plus d, where a is not equals to 0. Then sum of the zeros, that is alpha plus beta plus gamma, sum of the 3 zeros of the cubic polynomial is equals to minus b by a, where b stands for, it is coefficient of x square and a stands for coefficient of x cube. Therefore minus b by a is equals to minus of coefficient of x square divided by coefficient of x cube. That is sum of the 3 zeros of the cubic polynomial is minus b by a, that is equals to minus coefficient of x square divided by coefficient of x cube. Now sum of the individual products of 3 zeros of the polynomial, that is alpha into beta plus beta into alpha plus alpha into gamma, their sum is equals to c by a, where c is x coefficient, a is x cube coefficient, that is coefficient of x divided by coefficient of x cube. That is the sum of individual products of the zeros, that is alpha into beta plus beta into gamma plus gamma into alpha is equals to c by a, that is coefficient of x divided by coefficient of x cube. Now product of 3 zeros of the cubic polynomial, that is alpha into beta into gamma, product of 3 zeros of the polynomial alpha into beta into gamma is equals to minus d by a, where d is a constant term and a is coefficient of x. Therefore product of 3 zeros of the cubic polynomial alpha into beta into gamma is equals to minus d by a, that is equals to constant term divided by coefficient of x. So this is the relationship between zeros of the cubic polynomial with the coefficients of a cubic polynomial. Is it clear, children? Now we will discuss example 5. Verify that 3, minus 1 by 3 are the zeros of the cubic polynomial p of x is equals to 3x cube minus 5x square minus 11x minus 3. So we are given one cubic polynomial. Cubic polynomial means degree is 3. So what is the cubic polynomial? Here it is p of x is equals to 3x cube minus 5x square minus 11x minus 3. So this is the cubic polynomial which is given, and its 3 zeros are given, that is 3, minus 1 and minus 1 by 3. What we have to do? Then we should verify these are the these three, that is 3, minus 1 and minus 1 by 3 are the zeros of the given cubic polynomial or not. After verifying, then again we need to verify the relationship between the zeros and the coefficients of the given cubic polynomial. So these two parts are there. The first part we have to verify the given values of x are zeros or not. Here we use trial and error method, that is by substituting in the place of x as 3, x as minus 1, x as minus 1 by 3, and on simplification if we get its value is 0, then 3, minus 1 and minus 1 by 3 are the zeros of the given polynomial. Otherwise they are not the zeros of the given polynomial. So what is the given polynomial? Here it is p of x is equals to, given p of x is equals to what it is, 3x cube minus 5x square minus 11x minus 3. So we need to check whether the 3 minus 1 and minus 1 by 3 are the zeros of the given polynomial or not. So to check, substitute x is equals to 3, that is find p of 3, p of minus 1, p of minus 1 by 3. If we get on simplification as 0, then we can say that 3 comma minus 1 comma minus 1 by 3 are the zeros of the given polynomial. So let us find out. So p of 3 means x is equals to 3. Substitute x is equals to 3. That is 3 into x is equals to 3 means it is 3 cube minus 5 into x square means it is 3 square minus 11 into x means it is 3 minus 3. That is equals to 3 into 3 cube is equals to 3 into 3 into 3. 3 3s are 9, 9 3s are 27 minus 5 into 3 square is equals to 3 into 3 it is 9 minus into plus it is minus 11 into 3 it is 33 minus 3. 33 minus 33 and minus 3. Then multiply 3 into 27. 3 7s are 21, 3 2s are 6 plus 2 it is 8, 81, minus into plus it is minus, 5 into 9, 5 9s are 45, 9 5s are 45, minus 33 and minus 3. Now add all negative numbers, minus 45, minus 33 and minus 3 all are negative numbers. Add these numbers. Minus 45, minus 33 it is minus 78, minus 78 minus 3 it is minus 81. So 81 minus 81 is equals to 0. So p of 3 is equals to, we got 0. Therefore 3 is the 0 of the given polynomial. Is it clear? Now similarly you check for the second value which is given minus 1. That is p of minus 1 is equals to, now x is equals to minus 1, substitute in the given polynomial. 3 into x cube means 3 into minus 1 whole cube minus 5 into x square means it is 5 into minus 1 whole square minus 11 into minus 1 minus 3. Like this you substitute the value minus 1 in the place of x, then simplify. 3 into minus 1 whole cube, here the cube is 3 is there, that is an odd number is there, therefore you get a negative integer, that is minus 1 into minus 1 into minus 1 will get minus 1, minus 5 into minus 1 whole square, minus 1 into minus 1, minus and minus it is plus, 1 into 1 it is 1, next minus into minus it is plus, 11 into 1 it is 11 minus 3, now plus into minus, minus 3 into 1 it is 3 minus 3, minus into plus it is minus, 5 into 1 it is 5 plus 11 minus 3. Again add all negative numbers, minus 3 minus 5 and it is minus 3. Minus 3 minus 5 minus 8, minus 8 minus 3 it is minus 11. So minus 11 plus 11 is equals to 0 we got. Therefore we can say that minus 1 is also one of the 0 of the given polynomial. Similarly, find substitute that is x is equals to minus 1 by 3 and simplify whether you are getting the 0 or not. If you get 0, then we can say that the minus 1 by 3 is also 0 of the given polynomial. That is p of minus 1 by 3 is equals to 3 into x cube means x is equals to minus 1 by 3 whole cube minus 5 into x square means it is minus 1 by 3 whole square minus 11x means it is 11 into minus 1 by 3 minus 3. Then simplify 3 into minus 1 by 3 whole cube means minus 1 whole cube divided by 3 whole cube. Minus 1 whole cube means it is minus 1 into minus 1 into minus 1. That is minus into minus plus, plus into minus is minus. We will get minus 1 divided by 3 cube means it is 3 into 3 into 3. 3 3s are 9, 9 3s are 27. Next, minus 5 into minus 5 into minus 1 by 3 whole square means minus 1 whole square divided by 3 square. Minus 1 whole square means it is minus 1 into 1 it is plus 1. 3 square is equals to 3 into 3 it is 9. Therefore, we get this 1 by 9. Next, similarly, minus into minus it is plus. 11 into 1 it is 11. 11 by 3 minus 3. That is equals to 3 1s are 3, 3 9s are 27. Plus into minus, minus 1 into 1, 1 by 9 minus into plus it is minus, 5 into 1 it is 5, 5 by 9 plus 11 by 3 minus 3. Now take the LCM for the denominators. The LCM 9, 9, 3 and here it is 1. So for the LCM for 9, 9 and 3 it is 9 we will get, because 9 is a multiple of 3 and 9 is the multiple of 3, 9 is the least multiple of 9, or you can find the LCM at here for 9, 3, 3 and 1. So what we get for this LCM if you find here? So find the LCM of 9, 3, 3 and 1 at here, that is 9, 3, 3 and 1, that is 3 3s are 9, 3 1s are 3, 3 1s are 3 and 1. Multiply 3 into 3, 9, 9 into 1, 9, 9 into 1, 9, 9 into 1, it is 9. So therefore LCM is equals to 9. Now 9 1s are 9, 1 is the quotient, 1 into minus 1 it is minus 1. Again keep minus, 9 1s are 9, 1 into 5 it is 5, that is minus 5, plus 3 3s are 9, 3 into 11 it is 11 3s are 33. Next 3 means this 3 by 1, 1 9s are 9, 9 into 3 it is 27 minus 27 we will get. That is equals to, now add the negative integers. Minus 1 minus 5 is equals to minus 6, minus 6 minus 27 is equals to minus 33, minus 33 plus 33 divided by 9. That is equals to minus 9 minus 33 plus 33 is equals to 0. 0 by 9 we will get, that is equals to 0. That is equals to 0. Therefore P of minus 1 by 3 is equals to 0. From this what we can say that? We can say that 3 comma minus 1 comma minus 1 by 3 are the zeros of the given cubic polynomial. Like this we can verify whether they are the zeros of the cubic polynomial or not by substituting the given values in the place of x and on simplification. If we get 0 the value, then we can say that those values are zeros of the given cubic polynomial. Is it clear? This is the first part of the sum. Next we have to verify the relationship between zeros and the coefficients using the what we have discussed in the previous. Now the second part of the sum, that is verify the relationship between the zeros and the coefficients. So zeros are what it is? 3 minus 1 minus 1 by 3. Let it is let alpha is equals to 3 and beta is equals to minus 1, gamma is equals to minus 1 by 3. So now we are verifying here, verification between what? That is the relationship between the zeros and coefficients. Verification. So verification, sum of the zeros, that is alpha plus beta plus gamma is equals to minus b by a. We will verify whether it is satisfied or not, or verified or not. Alpha plus beta plus gamma. Alpha it is 3 plus beta it is minus 1 plus gamma it is minus 1 by 3. That is equals to b by a. B is equals to what? X square coefficient. B minus b by a, here it is. B is equals to x square coefficient. Here x square coefficient is minus 5. X cube coefficient is 3 and x coefficient is minus 11. Constant it is 3. Therefore minus of b is equals to minus 5 divided by, then x cube coefficient it is 3, that is a is equals to 3. Simplify. 3 plus into minus minus 1 plus into minus minus 1 by 3. That is equals to minus into minus it is plus 5 by 3 we will get on the right hand side. Left hand side simplify by taking the LCM. So LCM for 3 means it is 3 by 1, 1 means it is 1 by 1. Here the denominators are 1, 1 and 3. Therefore the LCM for 1, 1 and 3 it is 3. So 3 means it is 3 by 1, 1 3s are 3, 3 into 1 it is 3 minus 1, here it is 1, 1 3s are 3, 3 into 1 it is 3, sorry. So here denominator is 1, 1 3s are 3, 3 into 3 it is 9 we will get here, 9 minus, here 1 means it is 1 by 1, 1 3s are 3, 3 into 1 it is 3, minus 3 and then minus 3 is the denominator, 3 1s are 3, 1 into 1 it is 1, that is equals to 5 by 3. Now 9 minus 3 minus 1 is equals to minus 4. That is 9 minus 4 by 3, which is equals to 5 by 3. That is 9 minus 4 means it is 5. 5 by 3 is equals to 5 by 3. We got it. Like this we can verify the first one, that is sum of the zeros of the given cubic polynomial. Next it is alpha into beta plus beta into gamma plus gamma into alpha is equals to c by a. That is c means it is coefficient of x divided by a means it is x cube coefficient. Alpha into beta means it is 3 into minus 1 plus beta into alpha, beta into gamma is equals to minus 1 into minus 1 by 3 plus alpha, that is alpha into gamma or gamma into alpha, it is minus 1 by 3 into alpha is equals to 3, that is equals to c by a. C is equals to minus 11 by a is equals to x cube coefficient, it is 3, minus 11 by 3. Now plus into minus minus, 3 into 1 it is 3, plus into minus minus, minus into minus it is plus, 1 into 1 1 by 3. Now 3 ones are 3, 3 ones are 3 it is. Plus into minus minus, minus into plus it is minus, 1 into 1 it is 1, that is equals to minus 11 by 3. Now 3 minus 1 is equals to 3 minus 1, subtract these 2 will get 2. 2 plus 1 by 3, that is equals to minus 11 by 3. Minus 11 by 3. You see here, then here plus into minus it is minus, we get minus 3. Therefore minus 3 minus 1 is equals to minus 3, minus 1 is equals to minus 4 plus 1 by 3 plus 1 by 3. Now take LCM for left hand side, we get LCM is 3. 4 means it is 4 by 1. 1 3s are 3, 3 into 4 is 12, that is minus 12 plus 3 1s are 3, 1 into 1 it is 1, that is equals to minus 11 by 3. Minus 12 plus 1 is equals to minus 11 by 3, that is equals to minus 11 by 3. Now both sides LHS is equals to RHS, hence it is verified this one, the sum of the individual products of the zeros of the cubic polynomial. Now the third relationship, it is product of the zeros, that is alpha into beta into gamma is equals to minus d by a, minus d by a. Alpha is equals to 3 into beta is equals to minus 1 into gamma is equals to minus 1 by 3, that is equals to minus d is equals to minus 3 by a is equals to what it is 3. Substitute in the alpha place as 3, beta place as minus 1 and gamma as minus 1 by 3, d as minus 3. Now we can multiply. So here multiply here, 3 ones are 3, 3 ones are 3, both are cancelled. Plus into minus minus, minus into plus, minus into minus it is plus, 1 into 1 1, 1 into 1 it is 1, that is equals to minus into minus it is plus, plus 3 divided by 3, 3 ones are 3 ones are, that is 1 is equals to 1, that is LHS is equals to RHS, both the sides we got same, therefore it is verified. It is verified. So like this we can verify the relationship between the zeros and coefficient of a given polynomial when we know the zeros of the cubic polynomial. Is it clear, children? So simple it is, we need to substitute the given zeros in the place of alpha, beta, gamma and write the relationship, and both the sides you should make, if you get both the sides equal values, then it is verified, otherwise it is not verified. And in the last class we have discussed the relationship between zeros of a quadratic polynomial and cubic polynomial with the coefficients of cubic polynomial and quadratic polynomial, and how to find out the quadratic polynomial when we know sum and product of the zeros of a quadratic polynomial are known. So now in this class we are going to discuss about the division algorithm of polynomials. So this division algorithm already you have come across in the lower classes, that is division formula, which is nothing but dividend is equals to divisor into quotient plus remainder. That concept we can also, it is applicable for the polynomials. We are going to discuss for that. Before starting this division algorithm of polynomials, we will discuss for arithmetic. That is numbers. Division algorithm of numbers we discuss now. So what it is, division algorithm of related to this for numbers it is. See here. So if you take when we divide 7 divided by 2, 7 divided by 2, divide 7 with 2, what we get? 7 when we divide with 2, 2 3s are 6, 7 minus 6 it is 1, we will subtract. What we call this number 2 and what we call this number 7 and what we call this number 3 and what we call this number 1. The same terminology also applicable for a division algorithm of polynomials. So what we call this term, it is divisor. Divisor. What is this? It is divisor. And what is this? 7 is known as dividend. 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 And what about this 3? 3 is known as quotient. 3 is known as quotient. And 1 is known as remainder. 1 is known as remainder. So now we can check, we have studied in the lower class whether our division is correct or not. We will verify by using the concept of dividend is equals to dividend is equals to dividend is equals to dividend is equals to divisor into quotient. Divisor into quotient plus remainder. Dividend is equals to divisor into quotient plus remainder. So here dividend is equals to what? 7. We are going to check whether 7 is equals to the product of divisor and quotient plus remainder. So here divisor is equals to 2 into quotient is equals to 3 plus remainder is equals to, what is remainder? It is 1. So now as for the bottom rule, first we will multiply the numbers, then we will add the numbers. 2 into 3 is 6. 6 plus 1, that is equals to 7. So now LHS is equals to RHS. Hence it is verified. It is verified. Is it clear, children? So this is known as division algorithm of arithmetic, that is numbers. The same concept will also apply. It is applicable for the polynomials also. We will discuss that division algorithm of polynomials. Is it clear? Now we will discuss division algorithm of polynomials. Its statement is, it states that the given any polynomial p of x is a given polynomial, and any non-zero polynomial g of x. So we are given two polynomials p of x and g of x. They are non. So here especially g of x is non-zero polynomial, means g of x should not be a zero polynomial, means it is not zero. Other than 0, it can take any polynomial. There are polynomials q of x and r of x. So when two polynomials p of x and g of x are given, then there exist two polynomials q of x and r of x, such that how they are existing, such that p of x is equals to, that is the first polynomial, is equals to g of x into q of x plus r of x. Like what we have discussed, it is dividend is equals to divisor into quotient plus remainder. So here p of x is equals to g of x into q of x. Q of x is nothing but quotient polynomial. We call this as quotient polynomial plus r of x. R of x is nothing but remainder polynomial, and g of x is nothing but divisor polynomial. This is dividend polynomial, and there is a condition where r of x is equals to 0, that is remainder polynomial is equals to 0, or the other case it is the degree of r of x is less than degree of g of x, that is a divisor. Even in our general division also we have studied, always the remainder should be 0 or less than what it is, less than the divisor. It should not be more than the divisor, or it should not equal to the divisor. So the remainder is always 0 in the arithmetic. The remainder is always less than the divisor. The remainder is always less than the divisor in the arithmetic we have studied. But here, the remainder r of x, it may be 0, or if it is not 0 means the degree of r of x is less than the degree of g of x. That is, degree of the remainder polynomial is less than the degree of g of x. G of x is nothing but divisor polynomial. So two cases, remainder may be 0, or if remainder is not equal to 0, the degree of r of x should be less than the degree of g of x. If remainder is 0, what we call the divisors? We call the divisors are factors. What are factors? The numbers which leaves remainder 0 on division are known as factors. If we get remainder 0, we call the divisors are factors. Now, we will check it is simply what we can say in our own words is dividend polynomial is equals to divisor polynomial into quotient polynomial plus remainder polynomial, where remainder polynomial is 0 or the degree of remainder polynomial r of x is less than the degree of g of x. We will discuss whether it is satisfied or not for the polynomials with an example. So divide 2x square plus 3x plus 1 by x plus 2. Divide 2x square plus 3x plus 1 by x plus 2. Here the first polynomial 2x square plus 3x plus 1 is the p of x, and x plus 2 is the g of x. That is a divisor polynomial and it is dividend polynomials. So let p of x is equals to 2x square plus 3x plus 1, 2x square plus 3x plus 1, and g of x is equals to x plus 2. We have to divide this. How to divide the polynomials? We have studied in the 9th standard. There are few steps are there. I will revise those steps again. So while we are dividing, remember the few steps. Always divide the first term of the dividend with the first term of the divisor. First term of the dividend with the first term of the divisor to get the quotient. So when we get that quotient is multiplied the divisor, and we will write under the dividend that product. Then we will subtract, and we will repeat the same step. Again, second dividend which we get, from that divide the first term of the dividend with the first term of the divisor and repeat the process till we get the remainder. That is, when we can say that remainder, all the terms are to be taken out. All the terms are taken out for the division, or what I said here, the degree of the r of x should be less than the degree of g of x. When we come across the degree of r of x is less than g of x, our division is over. So now how to divide? So here 2 of this one, 2x square plus 3x plus 1 is there, right? 2x square plus 3x plus 1 is divided with x plus 2. So here you remember the first and foremost step is all the terms of both dividend and divisor should be in the decreasing order of their powers. Should be in the decreasing order of their powers. You see here x square power is 2, x power 1, what is the power? Here it is x power 0. It is in the decreasing order of their power. What about here the divisor? X power 1 plus 2 into x power 0. 1 and 0 are the powers, therefore it is in the decreasing order of their powers. So first step it is observe both dividend and divisor are in the powers are in the decreasing order or not. If they are not in the decreasing order, you regroup them in the decreasing order of the powers, so that our division will be simpler. Second step it is see any terms are missed in the given polynomial, either in the dividend polynomial or divisor polynomial. Leave some gap for that term, or you place 0. For our convenience. So then the third step is divide always the first term of the dividend. Here dividend is 2x square plus 3x plus 1. So the first term it is 2x square. Divide 2x square with what? The first term of the divisor. Here divisor is x plus 2. Its first term is x. So divide 2x square with x. Whatever we get the quotient, that quotient will write under the quotient place. Is that clear? 3 steps are there. We will continue. We will subtract and we will continue the same step. Third step will be continued. So first step, see all the powers are in the decreasing order. It is 2, 1 and 0 of the dividend, 1 and 0 for the divisor. Second step, all the terms are given All the terms are given. Third step, divide what it is. The first term of the dividend, it is 2x square. So 2x square, when we divide with the first term of the divisor, it is x. So 2x square means it is 2 into x divided by x. X and x are cancelled. So what we got, it is 2x. So write this 2x as the quotient here. 2x as the quotient. Then multiply the divisor with 2x. Multiply the divisor with 2x and write the product below the dividend. So how to multiply the monomials, binomials? We have studied in the 8th, even in the studied in the 9th class. So first we need to multiply the arithmetic signs. Then we need to multiply the numbers. Then we need to multiply the variables. While you are multiplying the variables, we use the laws of exponents. So here, plus is here, plus into plus it is plus. What is the coefficient of x? It is 1. 1 into 2, 2. Then x into x, it is x square. X power 1 into x power 1, it is 1 plus 4, it is 2. That is x square. Then plus into plus, plus 2 into 3, sorry, 2 into 2, it is 4, 4x. Now we need to subtract this. While you are subtracting, what to do? We have to change the arithmetic signs. Change the arithmetic signs. So what are the arithmetic signs here? Is minus, plus is there, we get minus, and this is plus is there, we get minus. Now plus 2x square minus 2x square, both will be cancelled, you get 0. Then plus 3x minus 4x. How to subtract the terms? Subtraction of the terms in the polynomials is nothing but subtracting their coefficients. Here coefficient is plus 3 and here the coefficient is minus 1. Means the subtraction of two integers, one positive integer and one negative integer. How do we subtract this? Just by subtracting the small number from the bigger number, and we will take the bigger number sign. So here which is the bigger? 4, and it is having minus sign. So subtract 3 from 4. 4 minus 3 is 1, 1x. So which 1x will get this minus, or simply minus x will write. Minus x. Then we will bring plus 1. This leftover term we need to bring, that is plus 1. Plus 1. So now it is the second dividend and it is again divided, it is same. Observe whether what it is, degree is less than this divisor or not. What is the degree of this polynomial? 1. And this is the degree of this polynomial is 1. Always this degree should be less than the degree of this divisor or 0. It may be 0. Now again let's continue the third step. What is the third step? Divide the first term of the dividend with the first term of the divisor. So now this is the dividend. Which is the first term here? It is minus x. Divide minus x with the first term of the divisor, that is x. So x and x are cancelled. Minus x is minus 1x. Therefore we will get this minus 1 as the quotient. So keep minus 1 at here. Then what multiply? Plus into minus, it is minus x into 1, or 1 into x, it is 1x, or simply it is x. Plus into minus, minus 1 into 2, it is 2. So now subtract. Plus minus sign is there, we get plus, and here minus is will get plus. Now subtract. So what is it? Is minus x and this is plus x. Both are cancelled, get 0. Now plus 1 plus 2. Both are addition, both are same sizes. So add the numbers. 1 plus 2, it is 3. So now this is a remainder, we got r of x. Remainder, it is r of x. And this is q of x. Q of x means it is quotient. This is what? G of x, that is a divisor, and it is what? P of x. We have taken already here, we represented what is P of x and what is G of x. Now division is over. Now we need to check whether, see, what is the degree of this polynomial? Degree of this polynomial is 0. Here the degree of this polynomial is 1. So as I said, it is degree of r of x should be less than the degree of g of x. Is it correct? Right. Next, what to do? We have to check whether it is satisfied or not. That is, the division whether it is satisfied or not by using this concept. Is it clear, children, how to do this division? So what are the steps to be remembered? First step, it is observe the terms of the given polynomials, that is p of x and g of x, that is dividend polynomial and divisor polynomial, should be in the decreasing order of their powers. Second step, it is if any terms are missed, we should take their place as empty, or we can take it as also 0. Then third step, divide the first term of the dividend with the first term of the divisor. Whatever we get the quotient, that you place in the quotient place, and then multiply with this quotient what divisor. Write the product, subtract. While you are subtracting, signs will change. That is, plus will become minus, minus will become plus. Then after that, you will get the second dividend. Again, divide the first term of the second dividend with the first term of the divisor. You get the quotient, that you place it here, and continue the same step. Like this, you will do the division. See that the degree of the remainder r of x should be less than the degree of the divisor polynomial. Here, degree of this is 3 constant. Its value degree is 0. 3 can be written as 3 into x power 0. X power 0 is 1. That's why its degree is 0, and here the degree is 1. It is satisfied. Now we will check whether it is satisfied or not. Now we will discuss the division algorithm. That is, p of x is equals to g of x plus g of x into q of x plus r of x. Here p of x is equals to what it is? 2x square plus 3x plus 1, that is equals to q of x is equals to what it is? X plus 2. It is multiplied with the q of x. Q of x is equals to quotient, how much we got? It is 2x minus 1 plus r of x, that is remainder, how much we got? 3. Now what to do? So multiply these two, that is x plus 2 into 2x minus 1. How to multiply this? Binomial by a binomial, use the distributive property. So multiply this total 2x minus 1 with x, and then total 2x minus 1 you multiply with the 2. Therefore it is x into 2x minus 1 plus 2 into 2x minus 1 plus 3. So multiply as usual. Plus into plus plus, 1 into 2 it is 2, x into x it is x square, plus into minus minus, x into 1 1x, or simply it is x, that is minus x, plus into plus plus, 2 into 2 it is 4x, plus into minus minus, 2 into 1 it is 2 plus 3, 2 plus 3. Now any add or like terms are there, you add them, or then any unlike terms are there, you keep them as it is. So here minus x and plus 4x is there like terms, minus 2 plus 3 are like terms, but here x square term we have only one term is there, write that term, it is 2x square minus x plus 4x. How to simplify this? So they are like terms, just subtract the what it is coefficients. Minus x coefficient is 1, that is minus 1, and here x coefficient is minus plus 4, so plus 4. Subtract minus 1 from 4, that is 1 from 4 will get what it is? 3. Then take the larger number sign. Simply it is 4x minus x, that is equals to 3x plus 3x minus 2 plus 3, or 3 minus 2 is equals to plus 1. So now what is the quotient? That is a p of x given a dividend polynomial 2x square plus 3x plus 1. What we got on verification? 2x square plus 3x plus 1. This is a p of x. Now both are equal or not? That is LHS is equals to RHS. Hence it is verified. So the division algorithm is verified. Hence it is verified. Hence it is verified. Hence it is verified. Like this way verify the division algorithm. So what is that statement of the division algorithm? It states that the given any polynomial p of x and non-zero polynomial g of x, there are polynomials q of x and r of x such that p of x is equals to g of x into q of x plus r of x, where r of x is equals to 0 or degree of r of x is less than degree of g of x. Like this we can verify this. So I told you here on division, if you get the remainder 0, we call that divisor is a factor. We will discuss with one more sum. Now we discuss exercise number 2.3, first bit. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. So in that the second bit. So what it is? Division of polynomial p of x by the polynomial g of x. We need to find quotient and remainder. So p of x is equals to what it is? X to the power of 4 minus 3x square plus 4x plus 5. G of x it is x square plus 1x minus x. Now what is the first step we have to follow or we have to observe when we are doing these divisions? It is the first step is see that both the dividend as well as the divisor they should be that their terms should be in the decreasing order of their powers. So here power 4 and here it is 2, here 1 and here it is 0. For constants always the power will be 0. Therefore it is in the decreasing order of their powers. Here x square and it is 1 which is 1 into x power 0. Here 0 we got and here it is 1. It is not in the decreasing order of their powers. So we should change, we should regroup this in the decreasing order of their powers. Then second step it is what? Observe that all the terms of the given polynomials are given or not. How would we know? When we observe the decreasing order of their powers, any power is missed, that means the term is missed. You see here x power 4, 3x square. So in between we have one more term should be there. What the term it is? X cube term should be there, but it is not given. It is not given means it is 0 only. So in such cases you place 0 or you leave some space and continue the division. Then third step as usual you should divide the first term of the dividend with the first term of the divisor. So now p of x is given here. It is p of x is equals to what it is? X to the power of 4 minus 3x square plus 4x plus 5. Now g of x is equals to x square plus 1 minus x. X square plus 1 minus x. So now we need to divide. So quotient, this dividend is equals to x to the power of 4 minus 3x square. Here the x cube term is not there. So write this as 0 x cube or simply 0 you can write. 0 x cube or simply 0 also you can write. Then minus 3x square plus 4x plus 5 plus 4x plus 5. It is divided with the dividend is a divisor x square plus 1 minus x. As it is not in the decreasing order of their power, so rearrange this in the decreasing order of their powers as what? X square minus x plus 1. X square minus x plus 1. Now 2, 1 and 0. It is in the decreasing order of their powers. That is x square minus x plus 1 is the divisor. So we need to write by regrouping this. By regrouping the terms we get x square minus x plus 1. Now 2 steps are over. Third step is always divide the first term of the dividend with the first term of the divisor. So here what is the first term? It is x power 4. So x power 4 is divided by x square. So what we get it is x power 4 means it is x square into x square, or you can write x into x divided by x square means x into x. It is x cancelled, x and x are cancelled, then x into x it is x square. So the quotient it is x square. Multiply all the terms with the x square. 1 into 1, 1. X square into x square it is x to the power of 4. Minus 2 plus minus. 1 into 1 it is 1. X into x square it is x cube. Plus into plus. 1 into x square it is x square. Now we need to subtract. So while you are subtracting, the plus sign will change it as minus. Minus will be plus. Plus will be minus. So x power 4 plus x power 4 minus x power 4 are cancelled. Plus 0 x cube plus x cube. 0 plus 1 x plus x cube is plus 1 x cube. So 0 plus 1 is 1. So we get it as 1 x cube or simply x cube. Minus 3x square minus x square. Minus x square means is minus 1x square. Minus 1x square. Minus 3 minus 1 is equals to minus 4. Add the number, same side is there. So minus 4x square. Then bring the next term. What is the next term? It is plus 4x. Now this will act as the second dividend. Divide the second dividend with the divisor, that is the first term of the second dividend, it is x cube. X cube is divided by the first term of the divisor, it is x square, that is equals to, so x cube means it is x into x divided by x square means it is x into x. X and x are cancelled, this x and x are cancelled, we have it is x. So in the quotient write it as plus x. Now multiply the divisor with the x. 1 into 1 it is 1, x square into x it is x cube, minus into plus it is minus, x into x it is x square or it is 1x square, plus into plus plus, 1 into x it is 1x or simply it is x. Change the signs, minus, plus, it is minus. Plus x cube, minus x cube, both are cancelled. Now minus 4x square, this is plus x square. Plus x square means plus 1x square. So subtract the different signs are there, minus 4 and plus 1. Subtract the numbers and take the greater number sign. So 4 minus 4 it is 3. 4 is the bigger number, it is having minus sign. Therefore it is minus 3x square. Minus 3x square. Now plus 4x minus x. Minus x in the sense minus 1x. Again different signs are there, subtract. 4 minus 4 is 3. 4 is the bigger number, it is having the plus sign. Therefore it is plus 3x. Next bring the next term. What is the next term? It is plus 5. Plus 5. Now again divide the first term of the dividend, third dividend with the first term of the divisor. That is minus 3x square is divided by x square. X square and x square are cancelled. We get minus 3. So write in the place of quotient as what it is, minus 3. In that place minus 3. Now multiply with minus 3. Plus into minus, minus. 1 into 3 it is 3x square minus 3x square. Minus into minus it is plus. 3 into x it is 3x. Plus into minus minus. 1 into 3 it is 3 minus 3. Now subtract. Minus sign is there, will get plus. And this is plus sign is will get minus. Here minus sign is will get plus. Now what we get is minus 3x square plus 3x square, both will be cancelled, we get 0. Plus 3x minus 3x, both are cancelled, we get 0. Plus 5 plus 3 is equals to 8. Plus 8 we get. Therefore 8 is equals to quotient, remainder, and quotient will be what? X square plus x minus 3. So quotient is equals to, therefore quotient is equals to it is x square plus x minus 3. Then remainder is equals to it is 8. Remainder is equals to 8 and quotient is x square plus x minus 3. Like this we will divide the dividends. For example, if we get remainder 0, then what we call this x square minus x plus 1. This is factor of the dividend. Is it clear, children? How to divide this? Is it clear? Right. And in the last class we have discussed division algorithm. Now we are going to solve one more sum by using the application of division algorithm, that is division of polynomials. Division algorithm of polynomials. See one question. Find all zeros of 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. If you know that two of its zeros are root 2 and minus root 2. So you are given one polynomial 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. And two of its zeros are given root 2 and minus root 2. The other zeros we need to find. Now I have a question. What is the degree of the given polynomial? It is 4. Therefore, how many zeros will have? It will have 4 zeros. As its degree is there, is 4. Therefore, the number of zeros are also 4. And 2 zeros are given. So still we need to find the 2 more zeros. How to find 2 more zeros? We will discuss. In the last before class we have studied, if alpha and beta are the 2 zeros of a quadratic polynomial, then x minus alpha and x minus beta are the factors. They are the factors. Is it clear? By using the factors theorem. So root 2 is the 0 of the polynomial 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. Then x minus root 2 is a factor. X plus root 2 is a factor. So from these two zeros, write two factors using the factors theorem. That is x minus root 2 and x plus root 2 are the two factors. So the product of these two factors is also a product of the given factors. For example, you take it is 12. For example, it is 12. So when we use 12, what are the factors of 12? 1 into 12, 2 into 6 is 12, 3 into 4 is 12. Now here you see 2 is a factor of 12, 6 is also a factor of 12. The product of these two, that is 2 into 6, 2 6 are 12. 12 is also a factor of 12. So the same concept we also can apply for this for the polynomials also. When two numbers are factors of a given number, then their product is also a factor for the given number. Let here p of x is equals to 2x power 4 minus 3x cube minus 3x square plus 6x minus 2, and alpha is equals to root 2, beta is equals to minus root 2 are the two zeros. To alpha and beta are the two zeros. Now what we can write from them now, that is x minus root 2 and x plus root 2. X minus root 2 and x plus root 2 are two factors of p of x. Are two factors of p of x. So if two factors we know, their product, the product of these two, that is x minus root 2 into x plus root 2, that is equals to, it is in the form of a minus b into a plus b, or a plus b into a minus b, algebraic identity. That is a square minus b square, which is equals to x square minus root 2 whole square. Square and square root are cancelled, get x square minus 2. X square minus 2. This is the product of the two factors. This product is also a factor for p of x. Is also a factor of p of x. Is also a factor of p of x. Now to find, say if you know one factor of a number, how do we find the other factor? By dividing the given number with the known factor, we get the other factor. Similarly, we know this polynomial. For this polynomial, it is a known factor. When we divide p of x with x square minus 2, we get quotient. That quotient is also a factor for p of x. That quotient is also a factor for p of x. So now, what to do now? We should divide this p of x. Divide p of x with divided by with what? X square minus 2. The quotient is also a factor of p of x. Now how to divide these two numbers, it is we will discuss here. Now p of x is divided by x square minus 2. We will do the division here. What is p of x? It is 2x power 4 minus 3x cube minus 3x square plus 6x minus 2. It is divided with x square minus 2. P of x, it is x square minus 2. So x square minus 2 here, the x term is missed. So we will take that as what? 0, or we will leave the gap. So therefore it is x square plus 0x minus 2. So how we got this 0x? As that x term is missed, we have taken it as what? Simply 0 you can take, or 0x also you can take. Now you see the decreasing order of the powers 4, 3, 2, 1 and 0. All the terms are given and all the powers are in the decreasing order. Now the first step is divide the first term of the dividend with the first term of the divisor. That is 2x power 4. 2x power 4 is divided by x square. So what we get? 2 into x power 4 as x square into x square. That is divided by x square and x square are cancelled. We will get 2x square. 2x square. So the quotient, first quotient it is 2x square. 2x square. So now multiply with the 2x square. Plus into plus plus. 1 into 2 it is 2. X square into x square it is x power 4. Plus 0 into 3 it is 0. Plus 0x cube. And minus into plus it is minus. 2 into 2 it is 4x square. Now subtract. This is minus. Plus is will get it is minus. And minus will get plus. Plus 2x power 4 minus 2x power 4 both are cancelled. Minus 3x cube minus 0x cube. So if you add 0 or subtract 0 from any number, what we get? Same number. Therefore it is minus 3x cube. Now minus 3x square plus 4x square. Two numbers with different signs. So subtract the numbers. 4 minus 3 is 1x square. That is 4 is the greater number. It is having plus sign. Therefore you get plus. That is plus x square. Next bring next term. That is 6x. So now what is the first term in the dividend? It is minus 3x cube. So divide minus 3x cube with the first term of the divisor, that is x square. So what we get is minus 3 into x divided by x into x. So x and x, this x and this x are cancelled. Therefore we get minus 3x. So right here minus 3x. Then multiply with the minus 3x x square plus 0x minus 2. Plus into minus minus 1 into 3 3. X square into x it is x cube. Plus 0 into 3 is 0x square. Minus into minus is plus. 2 into 3 is 6x we got. That is, now subtract. Minus is will get plus. And here plus is will get minus. Plus is will get minus. So now it is minus 3x cube plus 3x cube both are cancelled. Now it is plus x square minus 0x square. So when you add 0 to anything you get the same, that is plus x square, or simply it is x square. Plus 6x minus 6x we get 0 plus 0 or 0x. Then bring minus 2. The last term it is minus 2, bring it. Now what is the first term of the dividend here? It is x square. This x square is divided by the first term of the divisor, it is x square. So both will be cancelled, get 1. That is 2x square minus 3x plus 1. So with plus 1 you multiply. 1 into x square it is x square. 1 into 0 it is 0x. Minus into plus it is minus. 2 into 1 it is 2. Now subtract. This is minus and it is minus, it is plus. So plus x square minus x square are cancelled, get 0. Plus 0x minus 0x are cancelled. Minus 2 plus 2 are get cancelled. Now the remainder is 0. Remainder is 0. Therefore the quotient is also a factor of that. When remainder is 0, the quotient is also a factor. Therefore 2x square minus 3x plus 1 is also a factor of p of x. So what is the degree of this quotient we got? It is 2. It is a quadratic polynomial. Now you find the factors of 2x squared minus 3x plus 1, which is a quadratic polynomial. Again you will get 2 factors. From the 2 factors we can find 2 zeros. So those are the remaining 2 zeros of the given quadratic polynomial p of x. So next what to do? Split the middle term of this 2x squared minus 3x plus 1 or factorize this and find the zeros. Is it 3x done? What we have to do here it is now we'll find the factors of the quotient. That is let q of x is equals to, it is 2x square minus 3x plus 1. So to find zeros of this polynomial, what we will take? Q of x is equals to 0. That is 2x square minus 3x plus 1 is equals to 0. Split the middle term. So how to split the middle term? Find the product of the coefficient of x square and the constant term. So 2 into 1 it is 2. Factors of 2 it is 1 and 2. So 1 plus 2 it is 3. Minus 1 and minus 2 are also 2 factors. Minus 1 plus minus 2 is equals to what it is? Minus 3 will So when we multiply a into c, that is 2 into 1 is equals to what? 2. Factors of 2 are what it is? 1 into 2 is 1 pair, minus 1 into minus 2 is also one more pair of the factors we get for 2. Now we will choose this pair of factors. Minus 1, minus 2 is equals to minus 3x. Minus 3. So 2x square, it is minus 2x minus x plus 1 is equals to 0. From these two take 2 and x common, that is 2x common, then x, here it is minus 1, and here only 1 is the common, take minus 1 common, then what it is x, and plus is the plus printed as minus into minus, therefore it is minus 1, that is equals to 0. Now x minus 1 is a common factor, x minus 1 into 2x minus 1, 2x minus 1 is equals to 0. That is x minus 1 is equals to 0 or 2x minus 1 is equals to 0. So transpose minus 1 to that side, get x is equals to plus 1, x is equals to plus 1. So x is equals to plus 1 is, that is 1 is 1 0 of the q of x. Q of x is a factor for that, therefore x is equals to 1 is also a factor for the given, sorry, x is equal to 1 is also a 0 of the given polynomial. Now from this transpose minus 1 to RHS will get plus 1 and transpose 2 will get x is equals to 1 by 2, as 2x means 2 into x. When we transpose 2 to the RHS, it divides. Now x is equals to 1 and x is equals to 1 by 2 are the two zeros of q of x. As q of x is the factor for the given polynomial, therefore these two are zeros, are also zeros of what it is, the given polynomial. Therefore, what are all the zeros? It is x is equals to 1, x is equals to 1, x is equals to 1, x is equals to 1 by 2 are the two zeros, and root 2 comma minus root 2 are the zeros of given polynomial, or the zeros of given polynomial. Zeros of given polynomial. So like this we will find all the zeros of a fourth degree polynomial. So how we do it is from the given two zeros, write two factors using those two zeros and multiply those two factors. The product is also a factor for the given polynomial. So with that product, divide the given polynomial using the division steps of division, and we will get the quotient with the remainder 0. The quotient is also a factor for the given polynomial. Now find the zeros of the quotient which we got. We will get find the zeros of the quotient. Those zeros are also zeros of the given polynomial. So we will split the middle term for this quadratic polynomial. We will get x is equals to 1 and x is equals to 1 by 2. These 1 and 1 by 2 are the two zeros, and already it is given root 2 and minus root 2 are two zeros. Total 4 zeros are there for the given polynomial. So like this we will find the zeros of the fourth degree polynomial when two zeros are given. Is it clear, children? Yes? Now we will discuss exercise number 2.3, the fourth bit. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x. So we are given x cube minus 3x square plus x plus 2. This polynomial is divided by g of x. We don't know what is the g of x, and we need to find it. The quotient and remainder are given. Quotient as x minus 2 and remainder as minus 2x plus 4 respectively. Find the g of x. Find g of x. We need to find the g of x. Here what is g of x? G of x is nothing but what it is? Divisor polynomial. Remainder polynomial is given, quotient polynomial is given, and dividend polynomial is given. How to find the divisor polynomial? So the same concept we have studied in the lower class for the arithmetic. When 7 is divided by 2, or when 7 is divided by some number, the quotient is 3. Quotient is equals to 3, and remainder it is 1. Find the number which is divided. That is, find the divisor. Find the divisor. So here we have studied this kind of sums in the lower classes. That is, when 7 is divided by some number, we don't know that number with what we divided 7. That number is known as what? Divisor. And quotient it is 3, remainder is equals to 1. Find this number. What we did here is we have applied the division algorithm, that is quotient, dividend is equals to, that is 7 is equals to divisor, we don't know divisor, divisor into quotient it is 3 plus remainder is 1. So then what we did here is by using the BODMAS tool we have simplified d into 3 it is 3d plus 1. So transpose 1 to this side, what we get is 7 minus 1 is equals to 3d. Here d stands for divisor. D stands for divisor. Now 7 minus 1 is equals to what it is? 7 minus 1 is equals to 6. That is equals to 3 into d. Now transpose 3 to this side. LHS we get 6 by 3 is equals to d. 3 ones are 3 twos are 6. Therefore d is equals to what? 2. That is divisor is equals to 2. We can check it whether it is right or wrong. So when we divide 7 with 2, what we get is 2 3s are 6. 7 minus 6 it is 1. Now remainder is 1. Quotient is 3. Divisor is 2. So like this we found by using the concept of division algorithm in the arithmetic. Now the same concept we use to find the g of x, that is a divisor polynomial in this case also. By using the division algorithm of polynomials. Let us see how to find out. See here, right? What is given here is p of x is equals to x cube minus 3x square plus x plus 2. So g of x we don't know. Quotient is given q of x is equals to what it is? X minus 2. And remainder is given r of x is equals to minus 2x plus 4. What we have to find? G of x is equals to. We need to find g of x it is. Now using division algorithm, by applying division algorithm, division algorithm, when we apply division algorithm, what is the division algorithm here? It is that is p of x is equals to g of x into q of x plus r of x. Now write p of x as what? X cube minus 3x square plus x plus 2, that is equals to g of x we don't know, write this is g of x as it is into q of x q of x is equals to what it is? X minus 2. Now what it is? R of x is equals to plus 4. So plus r of x is equals to minus 2x minus 4. Minus 2x minus 4. Now transpose this r of x to this side, as it is added, therefore it is subtracted. It is subtracted. So when we transpose, what we get is x cube minus 3x square plus x plus 2 minus of minus 2x minus 4 minus 2x. So minus 2x, r of x it is minus 2x plus 4. R of x is minus 2x plus 4. Therefore minus 2x plus 4, that is equals to g of x into x minus 2. G of x into x minus 2. Now simplify this. X cube minus 3x square plus x plus 2. Minus into minus is plus 2x. Minus into plus is minus. 1 into 4 it is 4. That is equals to g of x into x minus 2. G of x into x minus 2. Now identify any common terms are there here. Is x plus 2x plus 2 and minus 4 we have common terms are there. So there is no common term for x cube and x square. So now what we get is, right, x cube as it is, x cube minus 3x square minus 3x square. Now plus x plus 2x, plus x is plus 1x. Plus 1x plus 2x is equals to 1 plus 2 is 3. Therefore it is plus 3x. That is now plus 2 minus 4. Minus 4 plus 2. So different signs are there. Subtract the number and take the greater number sign. So 4 minus 2 is 2. We get minus 2. That is equals to g of x into q of x is what is x minus 2. X minus 2. Now to find g of x, transpose x minus 2 to LHS, as it is multiplying, therefore it divides. That is equals to g of x is equals to x cube minus 3x square plus 3x minus 2 divided by x minus 2. Now we have to do the division. So division means what? See, first up it is all the terms, their terms should be written in the decreasing order of their powers. 3, 2, 1, 0, and here 1 and 0. It is written in the decreasing order of their powers. Then see that all the terms are there. When we find all the numbers in the decreasing order without missing any power, then we can see that all the terms are given. So here all the terms are given. Then start a division. That is x cube minus 3x square plus 3x minus 2. So it is divided by x minus 2. So what is the first term here? It is of the dividend is x cube, and here it is x. So x cube, when we divide with x, what we get it is x cube means this x into x divided by x. X and x are cancelled. X into x it is x square. X into x it is x square. So write x square in the quotient place. Then multiply. 1 into 1 1. X into x square it is x cube. Minus into plus it is minus. 2 into x square it is 2x square. That is then subtract. This is minus and it is plus. So now what we get? X cube plus subtract this x cube minus x cube, both are cancelled. Minus 3x square plus 2x square. Subtract minus 3 and minus plus 2, both are different sides are there. Minus 3 plus 2 will get minus 1. Minus 1x square, or simply it is minus x square. Then bring the next term, that is plus 3x. So now which is the first term here in the dividend? Minus x square. Divide minus x square with the first term of the divisor, that is x. We will get what? Minus x into x divided by x. X and x are cancelled, we will get minus x. That is minus x. Minus x. Then with minus x multiply x minus 2. Plus into minus, minus 1 into 1 1. X into x it is x square. Minus into minus is plus. 2 into x it is 2x. Then subtract. Minus will become plus. And here plus is there. Plus will become minus. Now minus x square plus x square, both are cancelled. We get 0. Plus 3x minus 2x. That is 3 minus 2 it is 1x. Or simply it is x plus x. Then bring the next term. What is the next term? It is minus 2. Now here which is the first term in the dividend? X. So divide x with the x. What we get it is x divided by x and x are cancelled, get 1. So it is plus 1. 1 into x it is 1x, or simply x. Minus into plus it is minus. 2 into 1 it is 2. Now subtract. X minus, this is signs which changes. See here it is plus is there, therefore we get minus. Minus is there, we get plus. Now subtract. Plus x minus x, both are cancelled. Minus 2 plus 2, both are cancelled. We get remainder 0. Definitely we should get the remainder 0. Now the quotient which we got, x squared minus x plus 1, will give us g of x. So g of x is equals to what? X cube minus 3x square plus 3x minus 2 divided by x minus 2. When we divide x cube minus 3x square plus 3x minus 2 with x minus 2, the quotient which we get, that will represent g of x. Therefore g of x is equals to x square minus x plus 1. So like this we will find the g of x. The same question. Sometimes g of x will be given, remainder g of x, this will be given, g of x is given, there is a divisor polynomial is given, remainder polynomial is given, and they are asking you to find the q of x, that is quotient. Sometimes quotient will be given, g of x will be given, and p of x will be given. They are asking you to find r of x. So that we can use either divisional order or general division also we can use to find the r of x. So is it clear children how to find here this g of x in this sum?